Right, this is January 07. Question 7. A potential divider circuit is shown in figure 7.1. The output voltage V0 is obtained between the terminals A and B. The variable resistors R1 and R2 have full ranges of 400 ohms and 100 ohms respectively, and the supply voltage is 20 volts. We'll just scan in a wee bit so you can see that a bit more clearly. When R1 is varied, so there's R1 there, is varied through its full range of resistance, the range of output voltage variation obtained between A and B depends on the value of resistance set on R2. So again, what we get here, even though this is being varied, is still dependent on how this is varied as well. The range of output voltage variation between A and B is a maximum when R2 is set to 0. In other words, when this arrow is down here and you have no resistance from this in the circuit. So what is the maximum range of output voltage? So you could have, well, obviously the maximum voltage that you could have across this is when there's no resistance here. In other words, whenever this is getting the full 20 volts. So that's your maximum value, 20 volts. And then the minimum is whenever you have got this adjusted right down to 0. Again, as if it's not in the circuit. And when that's adjusted, that would mean you'd be taking the terminal off here and one off here. So this is right up to the top here. So there's none of this voltage in the circuit, and therefore you would be getting 0 volts out there. State the required value of resistance R2 to obtain the minimum possible range of output voltage variation between A and B. When R1 is varied through its full range, calculate this minimum range of output voltage. So if we have a wee look back here, if we want a minimum range of output voltage between A and B, we have to make sure that this is at 0 and this is set at 100. And therefore you're getting 100 ohms of resistance in the circuit. So the answer is 100 ohms. And therefore the minimum range of output voltage across A and B is from 0 to, now if that's up at 100, then we're going to calculate the minimum range of the output voltage. So if this is at 100, that means you've got 100 ohms of resistance in the circuit, and we've got 20 volts altogether. And so what we're going to do is calculate V out. So V out is equal to V in times R1 over R1 plus R2. So just to recap again, if we go back to the circuit, we are going to get the minimum range of output voltage here whenever this is set at 400 and this is set at 100, because you're getting 400 out here, but obviously you'll get a maximum value if this is 0, but if this is set at 100, then you're going to get the voltage out here being a minimum, okay, and this is set at 400, and so you've got, in your calculation, it's 20 times 400 is R1 over 400 plus 100 in the bottom line, and that gives you 16 volts. So just to recap again, the minimum possible range of output volt variation is whenever this is at 100, and this is ranging from 0 up to 400. And so when this is at 400 and this is 100, this is when we get our maximum output voltage from here, but in the minimum of all the settings that there could be here. And so this is when this is at 100 and this is at 400. For the potential divider, both R1 and R2 are set to their mid-range values. Calculate the theoretical output voltage between A and B. So I'm just going to draw this. So you've got 20 volts. Now, if this is set at its mid-range, that means that you've got your potential. I should really put that in here. Yeah, from there. It goes from in there, not here. Okay, so you've got that set at in the mid-range there, and then the bottom one set in the mid-range. And again, I'm going to divide it into 2, and so you've got 50 and 50 here, and you've got 200 and 200 here. Okay, so really what have you got left? It's as if this 50 here isn't in the circuit. I'll just scan in a wee bit. That 50, it's as if it's not in this circuit. And you've got 50 and 200 here, so it's 250 in the top, and it's the ratio of the 250 to the 200 down here. And so the total voltage, or sorry, the resistance here is 250 for the top part and 200 at the bottom. And so V out is going to be V in, which is 20, multiplied by our R1 value is 200. And it's over 200 plus the 50. And that comes out as 8.89 volts. Just scan out a wee bit again. Last question. For the potential divider arrangement described in B part 1, a voltmeter of internal resistance 800 ohms is now connected between A and B. Calculate the difference between the measured value shown by this voltmeter and the theoretical value calculated in B part 1. So if I just put this in again, I'm just going to draw 250 in the top here, and then the bottom I've got 200 and 800. So first thing I'm going to get here is my total resistance in that parallel bit, product over the sum. And that gives a value of 160 ohms. The total resistance in the circuit is 250 plus 160, which gives you 410. The total current in the circuit is V over R, so that's with our 20 volts.